Good morning everyone, I'm Terje, and today I want to show you how to set up and run a hydrodynamic simulation in FEDEM. You will learn how to create and import a space frame, which has to be a beam model, typically imported from NX, which is shown in another video. And then I will learn you how to define the sea environment. That means the current and the waves and some other hydrodynamic properties. And I will show you how to set up and run the simulation. Here you see the beam model representing the tripod, and in FEDEM you can model the beams, you can apply the beam cross sections and everything, but in this example I used another option. I've imported a space frame from NX, which is a complete beam model in NX with certain beam cross sections and beam properties. So if you check here, this is one beam cross section with an outer diameter of 2.5 meters, inner diameter 2.38, and the only cross section which is supported in FEDEM is the pipe type, as you can see here. Then you can also activate hydrodynamic properties, and here you see that the buoyancy diameter here is 2.5 meter, and the same with the drag diameter, and that is equivalent to the outer diameter of the beam by default. And then you see that the drag coefficient is set to 1, which is typically for pipe, and you have a coefficient, an added mass coefficient CM for the fluid, and an added mass coefficient for the structure as well. So these are automatically set in FEDEM. Then for the different beams you can visualize the beam cross sections, or you can switch it on and off. So this is the structural part, and also the materials are defined here as well. You should also notice that you can import any type of part geometry in NX, in FEDEM, excuse me, and you can do buoyancy calculations for that one. And then you typically import a VRL file, but you should notice that FEDEM is not able to calculate perfectly the dynamic, hydrodynamic or hydrostatic properties. It's only for beam cross sections of the pipe type that will be calculated correctly. So if you want to import a ship model, you can do it in a VRL format, but it will only be the center of gravity, position, and the orientation that will be approximated. You can't expect FEDEM to do the proper hydrodynamic calculations. That will only be performed if you import a space frame with the beam elements, like this. Okay, the next thing you want to do is to define the sea environment. And here you can see that the water density is set to 1025 kilos per cubic meter. You add gravity, and then you can apply a wave function. And like this, we can check it out. This is just an ordinary sine function, and it has the frequency in this example of 0.125 Hertz, and the amplitude is set to 3 meter. Then we can save it here, and then you see this is the original sea surface level. You see also the water depth, it's set to 50 meters. If you change it to 60 meters, like this, and apply this wave function, you will see it when you save that this is the wave length displayed, and you see the depth. We can change it back to 50 meters. Save. Then you can define the current, and here in this example we can use a function which is defined in a text file with the extension .txt. We can set the domain for visualization, and we can show it here. Here you see that the water speed is 0 at the seabed at minus 60 meters, and from minus 10 meters and above it's set to 4 meters per second, which is the current speed at the sea level, at the top level. So when you have added these properties, then you can also define the current direction. In this direction it's pointing in the x direction, and you can use a scale function or a scale parameter if you, for example, have defined a user function which is going from 0 to 1 meter per second. Then you can scale it to the current speed at the sea level. Save. Okay, close. Then we can start the simulation, and in this example we simulate 60 seconds and we can run it, and then FEDEM automatically animate the hydrodynamics. You should also notice that at the bottom of this structure there is an RB2 element, which is enabling me to calculate the effective moments and forces at the sea, at the bottom level. That would be the support forces for the complete structure when it's when the current and the waves are acting. Okay, the next thing is to check out the results. The first thing that you probably want to do is to just animate the hydrodynamics. You can scale the speed, and then you can display certain graphs, and you can, for example, plot the current speed at different heights, and of the top of the splash zone you see that the sea level, the current level, is 0 above the sea level. That's why the black graph here is going to 0. Otherwise it looks like a sine function. And this is the sea speed at the joint. Well, let's have a look. The joint is here. It's the red curve. And we have the splash zone, which goes to 0. We have the bottom of the tower, which is here. And we have the bottom layer, which is pretty much 0 all the time, but it's 1 meter above the sea level, so it's not, it's like 1 meter per second at the bottom here. Then the wave elevation in the joint zone. It goes from ±3 meter, which is the wave height. Then the overall tripod moments, which is the effective moments at this point here, which is the center of the RB2 element. And you can display all kinds of forces, buoyancy forces, and forces due to the waves and the current, like this. That pretty much conclude my presentation of the hydrodynamics. You can also check out the user guide. It has some more information, but I must say that FEDEM is not a CFD program, but it can do certain hydrodynamic calculations for you. Thanks for watching.